faithfully delivering value by interpreting the world's best books. Hi, this is Sally Talking Books. Today, I'll interpret for you the book Climate Civilization History, subtitled 80,000 Years of Climate Change That Transformed the World. In the winter of 1812, Napoleon had almost conquered all of Europe. When he led his army to attack Russia, the last country on the European continent, he encountered a sudden, extreme cold snap.
In Tolstoy's War and Peace, it describes the weather conditions during that period like this.
The weather was brutally cold. Even crows froze stiff and kept falling from the sky. In this harsh environment, 300,000 soldiers in Napoleon's army died from the extreme cold, nearly two-thirds of the entire force. As a result, Napoleon had to withdraw from Russia, and he never really recovered after that. Many historians believe it was precisely this sudden climate shift that caused Napoleon's downfall, altering Europe's entire history. And this wasn't just a random event in human history. You could say that all of human development is deeply tied to climate change. The climate civilization history we're covering today will show you how climate profoundly shaped the birth and growth of human civilization. The author of this book, Tianjia Khan, is a member of the Japan Meteorological Society and head of the Tokyo branch of the Japan Weather Forecaster Association. In this book, the author compiles the latest research from paleoclimatologists worldwide, detailing how global climate shifts since humans left Africa 80,000 years ago have redirected human civilization. BRE. All right, now I'll break down the book's main content for you through three key questions. First, how human civilization emerged in cold climates. Second, how modern global climate changes have influenced human history. Third, how will the future global climate evolve? Let's start with the first question, how human civilization was born in cold climates. When people talk about global climate change, what you hear most about these days is probably global warming. But looking at Earth's billions of years of history, global cooling has actually been more common and had a massive impact. During global cooling periods, the ice sheets at the poles expand, and even temperate zones, which normally have 4 distinct seasons, get covered by glaciers year-round. Paleoclimatologists call these times ice ages or glacial periods. Research shows that in Earth's 4.5 billion year history, large-scale ice ages lasting millions of years have occurred several times, also known as major ice ages, and the one relevant to our human history is the last of these major ice ages, because it occurred during the Quaternion period in Earth's geological timeline. It's also called the Quaternion Ice Age. The Quaternary Ice Age started 2 to 3 million years ago and ended around 14,000 years ago. During this time, the global climate was generally very cold, and even many temperate regions like Eurasia were covered in snow and ice year-round. However, humans were born precisely during this Quaternary Ice Age, so paleoclimatologists call humans children of the Ice Age. Although called children of the Ice Age, Africa, where humans originated, is in the tropics and wasn't cold even during the Ice Age. But during this period, the African continent became extremely arid, and tropical rainforest areas kept shrinking. This change forced our ancestors, ancient apes who lived in trees, to come down to grasslands and coastlines to expand their search for food. In this process, they gradually learned to walk upright and use simple tools, also known as Homo erectus, during the Quaternary Ice Age. Although it was cold overall, there were relatively warm periods. For example, around 1 million years ago, Homo erectus began migrating out of Africa during one such warm spell. This is called the first human migration out of Africa. For instance, well-known examples like Peking Man and Europe's Neanderthals all arrived in Eurasia to live during this time. However, scientists have found through DNA research that Homo erectus isn't the true ancestor of modern humans. Our true ancestors are Homo sapiens, who emerged in Africa around 200,000 years ago. At that time, Africa was arid but not cold, and food was relatively plentiful, making it ideal for Homo sapiens to thrive. But Homo sapiens weren't satisfied with staying in Africa's comfortable cradle. 80,000 years ago, which was also a relatively warm period within the Quaternary Ice Age, Homo sapiens also began attempting to migrate out of Africa, known as the second human migration out of Africa. The impact of climate change on our ancestors began from this point. Homo sapiens first spread along the southernmost part of Asia, moving eastward gradually toward warmer regions like South Asia and Southeast Asia, but they never expected that the relatively warm climate was only temporary. 74,000 years ago, Earth suddenly became extremely cold again, putting Homo sapiens' survival to a tremendous test. According to scientists, the cause of this sudden cooling was the eruption of Mount Toba. Located in Sumatra, Indonesia, Toba is a supervolcano that's erupted multiple times in history, with its eruption 74,000 years ago being the most violent in millions of years.
This eruption lasted weeks, blasting millions of tons of ash into the atmosphere that spread globally, turning daylight into darkness for years.
With most sunlight blocked, global temperatures plummeted rapidly, even bringing prolonged winter to tropical regions. So how did this sudden catastrophe affect Homo sapiens? Research shows it triggered two major transformations in our ancestors. First, population collapse. Only a tiny fraction survived the brutal conditions. Genetic studies show modern humans have minimal DNA differences, less variation between Europeans and Africans than between two gorillas on the same hill. The reason? Most Homo sapiens perished in the extreme cold. All modern humans descend from that small group of survivors. Scientists estimate just 2,000 survived, and this disaster likely wiped out other human species like Peking man and Neanderthals. After this catastrophe, these few Homo sapiens became Earth's only humans. Beyond numbers, the second change was qualitative. These 2,000 survived for a reason. They had more advanced brains, with greater learning and adaptation abilities. For example, they developed new skills like clothing, having lost most body hair in Africa to dissipate heat. When climate suddenly cooled after leaving Africa, they couldn't regrow hair quickly, forcing them to learn alternative ways to stay warm. So they learned to make clothes.
So how did scientists figure this out? You might not believe it, but it was through lice DNA. Specifically, the lice in clothes.
Lice are parasites that have coexisted with humans throughout our evolution. Originally, they only lived in human hair. Those in head hair are called head lice. But body lice are different. They live in human clothing. After studying body lice DNA, scientists found they branched off from head lice around 74,000 years ago, proving it was during this period that humans invented clothes for warmth. The earliest human clothes were actually very simple, just made from animal hides. But it was precisely these simple clothes that allowed some Homo sapiens to survive Earth's coldest period. As Homo sapiens improved clothing designs, the warmth retention got better. This also helped them gradually adapt. They survived icy environments. After the 74,000 year ago cooling, until the Quaternary Ice Age ended 14,000 years ago, Earth experienced several extreme cold periods. During this time, Homo sapiens not only endured the cold, but expanded their habitats using the climate conditions. Why do we say that? Because while Homo sapiens could walk throughout Africa and Eurasia, they couldn't reach ocean-separated Australia and America. During cold periods, most Earth's water became glaciers, causing sea levels to drop. Studies show during the Quaternary Ice Age, sea levels were up to 130 meters lower than today. So straits between Eurasia and Australia or America narrowed or froze, letting Homo sapiens paddle canoes or walk across to reach these continents. By 14,000 years ago, Homo sapiens had conquered every Earth corner except Antarctica. Then Earth's last ice age, the Quaternary, ended as the planet warmed. Paleoclimatologists call post-ice age warm periods interglacials. From 14,000 years ago to now, Earth's been in a warm interglacial, changing human life. During the Ice Age, with freezing temperatures, human habitats were mainly caves. Starting 14,000 years ago, humans began leaving caves to live in forests and grasslands, building houses there. Meanwhile, their diet also changed. During the Ice Age, our ancestors had very little to eat. To survive, they often hunted large mammals collectively, like reindeer and wild horses. Though not particularly tasty, this animal meat was rich in fat, providing both satiety and warmth. After the Ice Age ended, with improving natural environments, human diets diversified. They began catching birds and fish, gathering mollusks from rivers, and picking various wild fruits. Thus, by 14,000 years ago, Earth's population rapidly grew to nearly 10 million. However, the interglacial period's warm climate was relative, still experiencing cold, warm fluctuations. For example, during the Younger Dryas period, about 12,900 years ago, global climate suddenly became cold and dry again. Why is it called the Younger Dryas period? Dryas is a herbaceous plant in the rose family. Geologists named this geological period after finding its remains in certain strata. Dryas remains appear in many strata layers, with the most recent found in 12,900-year-old deposits, hence naming this period Younger Dryas, to distinguish from older and Middle Dryas periods. So why did global climate suddenly turn cold and dry during the Younger Dryas? Research shows that as the Quaternary Ice Age ended, rising temperatures melted North American ice, forming a massive glacial lake called Lake Agassiz.
As water levels rose, Lake Agassiz suddenly breached its banks 12,900 years ago, flooding eastward into the Atlantic. Massive freshwater influx disrupted the Atlantic's key warm current.
The North Atlantic current was blocked and remained disrupted long term. This current is vital for transporting heat and moisture to Northern Hemisphere temperate zones, and its blockage caused the Northern Hemisphere's sudden cooling and drying. Since the Northern Hemisphere was humanity's primary habitat, this greatly impacted contemporary civilizations. The Younger Dryas period began around 12,900 years ago and lasted until 11,600 years ago, spanning 1,300 years. Although this period was far less icy than the major ice ages, it still severely impacted people's lives. Due to the colder, drier climate, food from hunting and gathering drastically decreased, falling far short of the needs of the rapidly growing population. To get more food, humans used their smarts again and started trying to domesticate wild plants and animals. So it was climate change that drove the rise of agriculture and transformed people's lifestyles. Farewell to the hunter-gatherer life. Humans began living in large groups, forming villages and cities, and gradually transitioning to modern civilization. Okay, we've covered the book's first question: how global climate change affected humanity's birth and civilization's development. Humanity was born during the Quaternary Ice Age. Our ancestors, Homo sapiens, endured the test of extreme cold and battled the frigid conditions. In that struggle, they learned survival skills like making clothes and spread their reach worldwide. The Younger Dryas period, around 12,900 years ago. Humans developed agriculture while fighting cold, arid climates and step-by-step moved toward modern civilization. As human civilization advanced and productivity grew more sophisticated, climate's impact on us has always remained. Now, let's dive into the book's second question. How has climate change influenced human history in modern times? From about 12,900 to 8,000 years ago, Earth went through multiple periods of cooling and drying. This was all caused by meltwater from Lake Agassiz flowing into the ocean. Starting around 8,000 years ago, ice and snow in Earth's temperate regions mostly melted. After that, large-scale permanent glaciers were only in polar regions, with no more major ocean current shifts Therefore, beginning 8,000 years ago, Earth's climate entered a relatively stable, warm period. And with warm, steady weather, large-scale farming became possible. Only by supporting more people could civilization truly flourish. Thus, starting around 8,000 years ago, the four ancient civilizations, ancient Egypt, ancient Babylon, ancient India, and ancient China, rose one after another, representing the peak of human agricultural achievement back then. However, global warming doesn't always benefit humans. For example, it causes uneven dryness and wetness worldwide, with some areas flooding and others facing severe droughts. And, for instance, archaeologists, through excavations in the Black Sea, infer that the biblical legend of the Great Flood likely stems from changes there. Today, the Black Sea is a true sea connected to the Mediterranean via the narrow Bosporus Strait. But 8,000 years ago, global sea levels were lower, and the Bosporus Strait was still land. So back then, the Black Sea was just an inland lake, with water levels 100 meters lower than today. The shores were home to many residents and once the most developed farming civilization area. Yet around 7,600 years ago, as temperatures rose, glaciers melted, and sea levels kept climbing, seawater suddenly broke through. The Bosporus Strait, originally land between the seas, allowed seawater to flood into the Black Sea, raising its level by 100 meters quickly. Lakeside human settlements were destroyed overnight. Warming caused frequent floods in temperate zones, but extreme droughts in subtropical areas. For example, the world's largest Sahara Desert was covered in vegetation about 8,000 years ago, even with a massive lake over 600,000 square kilometers. But global warming shifted atmospheric circulation, reducing rainfall there, eventually turning it barren. From 8,000 years ago, though global climate warmed overall, small fluctuations often made it dry and cold again. Persistent cold drought often dealt devastating blows to ancient states. For instance, around 4,200 years ago, the falls of the Sumerian and ancient Egyptian dynasties were due to climate shifts. During this time, a roughly 100-year cold, arid climate hit the northern hemisphere, especially severe in West Asia and North Africa, devastating agriculture and causing these ancient civilizations decline. Besides, the decline of the ancient Roman Empire was also tied to cold, arid climates. Around the 2nd century BC, thanks to warm, humid weather, the ancient Roman Empire gradually rose along the Mediterranean coast. But this changed 400 years later in the 2nd century AD. As the climate turned cold and dry, crops failed year after year, leading to constant internal conflicts and foreign invasions. The ancient Roman Empire thus began its decline. Meanwhile, from the 2nd century BC to the 2nd century AD, China experienced the stable and prosperous Qin and Han dynasties, largely thanks to warm, humid weather and thriving agriculture. So, after the 2nd century AD, as climate grew colder and drier, widespread hunger caused social unrest, a key reason for the Eastern Han dynasty's fall. From this point, China entered the relatively chaotic era of the Three Kingdoms, Jin, and Southern dynasties. By the 9th to 13th centuries, Earth entered another warm, humid phase. Europeans call this the medieval warm period. During this time, European agriculture boomed and populations surged. Stunning Gothic structures like Notre Dame, Canterbury Cathedral, Westminster Abbey, and Cologne Cathedral rose across Europe then. This symbolized well-fed, warmly clothed Europeans, pursuing higher life aspirations, roughly matching China's Tang and Song eras under warm, moist conditions, which also propelled Chinese civilization to its zenith. Over recent millennia, cold, dry periods often triggered mass migrations. With homelands turning harsh and people starving and freezing, many groups had to migrate en masse. Fighting broke out over resources, leading to constant warfare. For example, in Europe, Germanic tribes originally lived in central North Europe but moved south into Roman territory due to cold droughts clashing with the empire. Now, Similarly, in China, whenever cold droughts hit, northern nomads like the Zhou or Mongols would invade south to fight Chinese dynasties for grain. Yet these migrations also fostered cultural exchange and integration, a positive side for human progress. Beyond this, the author argues modern cold or dry periods often bred philosophers, as ethnic blending and clashing ideas sparked new thoughts. Religions and philosophies born then also spread more easily among people suffering social chaos and civil wars. For example, one of the most typical cold, dry periods was from 2,800 to 2,400 years ago. That is the 8th century BC. To the 4th century BC, during this period, there emerged religions like Buddhism and Judaism. You might ask, Buddhism originated in tropical India, right? Correct, but our cold, dry periods are relative. The 6th century BC, when Siddhartha Gautama lived, was a relatively cold, dry period in India. Similarly, ancient Greece birthed foundational Western philosophers like Socrates, Plato, and Aristotle during this era. Meanwhile, in China, during the spring and autumn and warring states periods, numerous philosophers emerged, including Confucius and Laozi. The most recent, exceptionally cold period was from the 15th century to mid-19th century, called the Little Ice Age by scientists. With abundant surviving records from this era, climatologists have extensively studied it. Over these nearly 500 years, cold wasn't constant. Significant fluctuations occurred, with exceptionally cold spells lasting decades to centuries, recurring periodically. The three longest cold periods were 1450 to 1570, 1645 to 1715, and 1770 to 1830. Each extreme cold wave profoundly impacted human civilization. Materially, every cold spell severely disrupted agricultural production. For instance, in late 15th century England, cooling forced abandonment of vital grape crops. Continental Europe saw repeated crop failures, famines, and even cannibalism. Hundreds of French villages became ghost towns during this time, and Asia fared no better. In Japan, records show cold, dry weather caused food shortages, skyrocketing rice prices, mass starvation deaths, and occasional cannibalism. Famines starved multitudes, causing negative population growth in many nations. To survive, people had to migrate. For example, from the 15th century onward, many Chinese and Japanese sought livelihoods in warmer Southeast Asia, reclaiming farmland or trading. Research shows that in Earth's 4.5 billion year history, large-scale ice ages lasting millions of years have occurred several times, also known as major ice ages. And the one relevant to our human history is the last of these major ice ages, because it occurred during the Quaternary period in Earth's geological timeline. It's also called the Quaternary Ice Age. The Quaternary Ice Age started 2 to 3 million years ago and ended around 14,000 years ago. During this time, the global climate was generally very cold, and even many temperate regions, like Eurasia, were covered in snow and ice year-round. However, humans were born precisely during this Quaternary Ice Age, so paleoclimatologists call humans children of the Ice Age. Although called children of the Ice Age, Africa, where humans originated, is in the tropics and wasn't cold even during the Ice Age. But during this period, the African continent became extremely arid, and tropical rainforest areas kept shrinking. This change forced our ancestors, ancient apes who lived in trees, to come down to grasslands and coastlines to expand their search for food. In this process, they gradually learned to walk upright and use simple tools, also known as Homo erectus, during the Quaternary Ice Age. And although it was cold overall, there were relatively warm periods. For example, around 1 million years ago, Homo erectus began migrating out of Africa during one such warm spell. This is called the first human migration out of Africa. For instance, well-known examples like Peking man and Europe's Neanderthals all arrived in Eurasia to live during this time. However, scientists have found through DNA research that Homo erectus isn't the true ancestor of modern humans. Our true ancestors are Homo sapiens, who emerged in Africa around 200,000 years ago. At that time, Africa was arid but not cold, and food was relatively plentiful, making it ideal for Homo sapiens to thrive. But Homo sapiens weren't satisfied with staying in Africa's comfortable cradle. 80,000 years ago, which was also a relatively warm period within the Quaternary Ice Age, Homo sapiens also began attempting to migrate out of Africa, known as the second human migration out of Africa. The impact of climate change on our ancestors began from this point. Homo sapiens first spread along the southernmost part of Asia, moving eastward gradually toward warmer regions like South Asia and Southeast Asia. But they never expected that the relatively warm climate was only temporary. And agriculture is especially vulnerable to climate influence. Since modern times, although the major ice age has ended, climate fluctuations still occur. During relatively warm and humid periods, agriculture thrives, and civilizations and nations enjoy stability and prosperity, whereas during colder, drier periods, agricultural production suffers, forcing migration that sparks continuous warfare. However, cold and dry periods also spark new ideas that drive human progress forward. Given climate's huge historical impact on civilization, we must monitor global climate trends. It shapes humanity's future. Now let's explore the book's third question. How will Earth's climate change in the future? First, we need to understand the factors driving global climate change. Modern research shows numerous factors broadly categorized as extraterrestrial and terrestrial. Let's start with extraterrestrial factors. We all know the sun is Earth's primary heat source, with solar activity cycling periodically. When solar activity peaks, Earth receives more heat. Temperatures rise. The reverse cools us down. Some scientists believe solar wind strength also affects climate. It reduces cosmic rays that help form atmospheric clouds. Studies show Earth's current average cloud cover is 65%.
Weaker solar wind increases cloud cover, lowering temperatures. Stronger wind does the opposite.
Additionally, Earth's orbital behavior changes under gravitational influences from the sun and planets. Like a spinning top, Earth's axis constantly shifts slightly. Currently, Earth's axial tilt is 23.45 degrees. Long-term data shows this tilt varies between 22 and 24.5 degrees. Don't underestimate these few degrees. They massively impact Earth. A larger tilt angle means more solar heat reaches Earth, raising global temperatures. Conversely, smaller angles lower temperatures. Besides, asteroid impacts on Earth also affect global climate. For example, 65 million years ago, an asteroid impact kicked up dust that blotted out the sun, preventing sunlight from reaching the ground long-term, causing global cooling that ultimately led to dinosaur extinction. However, compared to extraterrestrial factors, terrestrial factors cause more global climate changes. The supervolcano eruptions, melting glaciers draining into oceans, and disrupted ocean currents we mentioned earlier are all major drivers of global climate change. Additionally, continental drift, mountain building movements, and atmospheric composition changes are also significant climate change causes. First, continental drift. The Ice Age beginning 35 million years ago relates to Antarctica's drift. Research shows the South Pole area was once ocean like the North Pole. Antarctica was originally in temperate zones connected to Australia and South America, but starting 50 million years ago, it gradually separated and drifted to its current position. Meanwhile, the Antarctic Circumpolar Current formed, perpetually surrounding the continent, blocking all warm currents. Combined with the highly reflective white ice sheet, this prevented heat absorption, making Antarctica Earth's coldest region. Antarctica's average annual temperature is minus 56 degrees Celsius, while the Arctic's is plus 8 degrees Celsius. Moreover, 15 million years ago, as seafloor geology changed, the Tonga Trench gradually formed in the Pacific, connecting Antarctic waters with mid to low latitude Pacific regions. Thus, frigid seawater continuously spreads through this trench from ocean depths throughout the Pacific. So Antarctica acts like a giant refrigerator, constantly cooling Earth to prevent overheating. Beyond continental drift, mountain building also affects global climate. 7.2 million and 3.4 million years ago, rapid uplift of the Himalayas and Tibetan Plateau blocked warm, moist air currents from the Indian Ocean. This prevented warm, moist air from reaching Asia, causing sharp cooling across most northern hemisphere regions. Additionally, atmospheric composition changes cause global climate shifts. For example, increased greenhouse gases lead to global warming. Since the 18th century Industrial Revolution, increased fossil fuel use has gradually raised atmospheric CO2 and other greenhouse gases, especially over the last 50 years, with concentrations growing by 1 to 2 parts per million annually. This has caused sustained global warming over recent decades. Thus, climate change triggers are numerous and highly complex. How global climate will change remains hotly debated in scientific circles. The IPCC's 2007 report predicted that based on current greenhouse emissions and temperature trends, global temperatures will keep rising through the 21st century, reaching 2 degrees Celsius higher by 2110. However, most scientists predict long-term cooling, possibly even a return to an ice age. Why is that? Scientists believe cooling has dominated Earth's geological history. Current warming is temporary, driven by excessive fossil fuel use. Centuries from now, when fossil fuels deplete, global cooling will likely begin. More factors trigger cooling: supervolcanoes, asteroid impacts, or even warming-induced shifts like ocean current disruptions than warming. We call the Younger Dryas period, 12,900 years ago, sudden cooling from glacial meltwater, flooding oceans and blocking currents. Today, Greenland and Antarctic glaciers could repeat this. Warming melts ice, disrupting currents, and triggering rapid global cooling. Climatologist Wallace Broecker warned of a 1% risk of drastic climate swings within the next millennium. Such violent fluctuations, whether cooling or warming, would devastate human civilization. Despite advanced technology, humanity may still be powerless against abrupt climate shifts. Therefore, further research on climate change is crucial for humanity. All right, we've now covered the third part of the book. Many factors drive global climate change, extraterrestrial and terrestrial, making future shifts still unpredictable. Due to rising greenhouse gases, global temperatures are currently increasing significantly. However, some scientists believe long-term global cooling poses greater risks. Yet, whether cooling or warming, drastic climate fluctuations would severely impact human civilization. Hence, deeper research into climate change is essential. Okay, that's the core content of the book. Humankind emerged during the Quaternary Ice Age. Over 80,000 years, climate change has profoundly shaped civilization's course, permeating every aspect of material and spiritual life. While technology lets us alter local weather, like artificial rain or hail suppression, we remain powerless against global climate upheavals. Climate will keep influencing humanity's destiny. Our co-written history with it continues. All right, that concludes our journey through climate civilization history. Reading notes are below the audio. Until tomorrow!